0, this divider here, or this coupler, will produce me a sample of the A in this line and a sample of the B this line. I split my A and B by simply playing that game. Now, how much is D now that makes it a 0? That means what kind of a D that makes us a -1, right? That means 2 beta D should be pi. That requires 2 beta D equals to pi. Because pi gives you a -1. E to the j pi gives you a -1. And beta is 2 pi over lambda, so that's 4 pi over lambda times D is equal to pi. That means D is lambda by 4. Another miracle of the lambda by 4 number. You make the distance lambda by 4, and you split your signal based on direction. Signal coming from here comes out this way, signal coming from here comes out that way. This doesn't produce any input here, this doesn't produce any output. So the device now, in the S parameters, has a 4-port situation, right? We have 4 ports. Again, let's throw the device that way. And typically what we do is draw arrows like this. 1. That means this signal follows this path, and that path comes out here and there. Well, this signal goes out this way, and comes out this way, and this way. So we're going to call this 1, 2. Now, believe it or not, textbooks and references name these differently. 3 and 4 is not always the same notation. Here's one notation. Some other people call 3 and 4, right? So what's the S parameters here in this case? Can we write it by inspection? We have a 4 by 4. Assuming this is a perfect and ideal line, no losses, I'm going to ignore delay beyond this point. So this delay is not counted, so just a second. I'm just focused on this part 1. Because there's additional delay coming from the rest of the lines, which you can do later on. You see, here's my directional coupler, that matrix that I'm going to develop, and here's a piece of line here and a piece of line there, and combine, right? You can always do that. So complicating things by putting the delay on both sides in one problem is too much work. Let's just do this part and then add the delays if we need to. How much is reflection in 1? We claim is 0. It's a perfect line, and the leakage doesn't affect it. So that's, I'm going to say here, approximately. Approximation, obviously, is for a good reason, right? It gets too complicated if I'm going to do the whole thing. Likewise, you can think of this transmission property here, depending on how you make this. This could be very symmetrical. This could be the main line and this could be the leakage line, right? I can design it that way. So here's a place where the device physics is important. Was it designed to be symmetrical, or is it really this is the main line and this one just a secondary line with a different characteristics? But I'm going to assume that there are identical lines with just leakage like we saw here. So zeros. From 1 to 2, I get my signal. Supposedly 1. And from 2 to 1, supposedly 1. So I can put 1 here and 1 there. But I'm going to put it between quotes for now. Because if it's really 1, then obviously the rest of it has to be 0. Right? Power-wise. The total sum of these powers must equal to 1. The total sum of these squares should equal to 1. So if that's really 1, right? It should be 1 minus a tiny bit. So to correct that, it's going to be 1 minus some delta. 1 minus some delta. Okay? And that delta is related to the power that is going to leak in the other device. Now, between 2 and 4, there is a 0. And so is between 4 and 2. So that's 4 and 2, there is a 0 here. And 2 and 4 is a 0 there. That's perfect isolation here, between 2 and 4. 4 doesn't see 2, and 2 doesn't see 4.
So how do we know that when 2 goes across the other line, some of it doesn't also travel back towards 4?
Because we played the game here. If this is the way we design it, a signal coming from B is going to sum up here and cancel there. Look at this. That's really your 2, 4 element. And if this is 0, then this is also 0. All right? Between 1 and 3 is perfect isolation. We have it in blue here, right? That's 1, 3. And that was 2, 4. Four, 2, 2, 4, 1, 3, 3, 1. Between 1 and 4, there is that element here, which we said what? Here it is. 2k e to the minus j beta d. How much is e to the minus j beta d? Already know beta d, right? So 2 beta d is pi. So that's a pi over 2. So that's a j, right? So that's a 2jk if you wish. J2k, whatever. Likewise, between 4 and 1, 2jk. Between 4 and 1, it's coming down to 2 and 3 are here, 2jk. 2jk. Did I do anything wrong? I'm missing 3 and 4. 3 and 4 is 1s again. Yes, 1 minus delta again. 1 minus delta. I'm giving this example in particular because it has a practical application that we are using in our network analyzer, and we see many, many applications. Right? At the same time, it's a practice for discrete parameters. Obviously, I'm not doing a perfect job here, but I'm giving the concept. Right? Another device that's very important also is called the circulator. Right? Basically, let me show you why do we need that. It's a directional coupler, but has a different characteristics. Again, I'm going to draw my line as a single line. Okay, here's my line. All right, and then I'm going to go up a tower and have a radar send the signal and get reflection back. And I'm sitting here, I need a monitor here. And the monitor needs to separate these two signals from each other, A and B. The problem is your B signal coming back is very weak. Very, very weak. And if you just put it through the same sampler that samples the A is very strong. They're sending a very strong signal here and you're getting a very weak reflection. Well, this direction coupler treats both these the same because assuming they are the same levels. But if one of them is very high and the other one is very low, you can't afford to do losses on your, or attenuation on your return signal. So you'd like your B signal to be full and healthy, right? Because to start with, it's very weak. Same time, if you put these together on the same thing, your monitor to be sensitive enough for the B is going to burn out from the amount that you put through the A. Even the leakage from the A will burn out your monitor. If you weaken out your monitor sensitivity or increase your sensitivity that you can detect the B well, you can do that. So we come up with a device called the circulator. It allows the signal to flow in one direction and not the opposite way. I'm out of time and we'll cover that in more detail later on. I wanted to spend a minute again on the midterm that you had received today. All right. I don't know if there are more people missing today or not. You have a sealed envelope, sorry, all right, that you only open when you are ready to start working on it, all right? And you will have 3 hours. You time yourself, you go for 3 hours, and when you are done, you seal it again, and you return back to me no later than Wednesday. You are allowed open book and open chapter 2, which I have on Scholar. These are the only 2 resources that you are allowed to open. You can study as much as you want before you start the exam, okay? So you can leave that until, Tuesday night and start working on it then. That's fine with me. No discussions or no consultation. If you have any questions, you send to me by email. You don't ask me to meet in person because I will answer the question to everyone in class by email as well.